Hello everyone, my name is Aoyu and I'm a PhD student here working at CBE, and today I would like to present a study that focuses on how to perform HVAC functional performance tests automatically during recommissioning process. So HVAC commissioning is a process to ensure that everything works as design intended. So recommissioning is to periodically repeat the process for the existing system during operation. And some of the benefits we found in the literature and in the report shows that commissioning the existing buildings could save around 10 to 30% of energy with a simple payback. And functional performance test is at the heart of the recommissioning and commissioning process. And this is the process typically checks the basic functions and reporting the test results and diagnostics. So it is the final validation that the system actually works together as intended. However, the current industry is not doing this step properly, and the value of it is often being overlooked. And this is because a comprehensive HVAC functional performance test is often perceived as time and labor intensive, and the commissioning agent often needs to deal with a vendor-specific system configurations. And unfortunately, that configuration is highly repetitive. And this leads to one major challenge in practice, that is to overcome the fragmented point naming issues in the building automation system, which is a centralized computer-based controller for the mechanical system. And because the naming convention of those points were not standardized at all, so finding a specific data points in those systems can be very annoying. And here is an example when we first look at the BIS system in our environment chamber at CBE. So you can see the naming convention of the points normally consists of abbreviations and symbols and random ID numbers. And actually, we found 1,000 points that in our system. Until this day, I still do not understand 20% of the points. And for even larger commercial buildings, there could be 10,000 points that are all like this, which are unstructured. So in order to make the recommissioning process less expensive and easier to do, we believe it is critical to think about how can we streamline and scale the HVAC functional performance test, which is the objective in our study. So first, we would like to develop a streamlined workflow, and with the workflow and tools developed, the building managers can run the test more easily and regularly to see whether the system is operating efficient. And the second objective we're trying to push is to generalize the workflow. This means the same workflow that developed here can run in other buildings directly without this time-consuming and complex configuration. And this is a real problem for commissioning and recommissioning because the commissioning agent might not be the same person who designed the system. And for the method, we'll be leveraging a standardized metadata schema called Break to automate the whole process from data querying to sequence implementation and results analysis. And we will demonstrate this using the ventilation system at the CBE environment chamber. So break schema is not exactly what Angelo talked about in the LCE analysis as a material, but here is a tool developed to overcome the fragmented and vendor-specific naming issues in buildings, because it provides a standardized semantic descriptions for the building operational data. And here is an example. The figure here shows the original data points we found in the BIS system. So the break schema would specify that some of the points are tagged as equipment devices, and some of the points are tagged as sensor measurements. But most importantly, the break schema would specify the relationship between those data points. So it organizes the unstructured data points to a structured format. And in order to retrieve the information from the graph, we need to submit queries, which is a standardized and machine-readable language. And in our study, we use the break query to get all the data points we needed to run the functional performance test for the ventilation system. So that includes the supply airflow sensors at the HVAC zone. And with the tagging and semantic descriptions shown here, the brake schema would automatically tell us whether there are any measurement points available. And in this case, there are two, which are highlighted in green here. One is measuring the airflow rate at the VAV box. The other one is measuring at the diffuser. So you can see by leveraging brake schema, we no longer need to retrieve information manually. And the advantage of a standardized brake query is that it is highly reusable without hard coding requirements. And that means the same query that developed in our chamber can run in your buildings directly as well. Therefore, we develop our streamlined workflow on top of that, and with the information data points retrieved from the brake query, you can include them in testing sequences. And this allows us to, for example, read the current data stream and write new set points to the system. And then we add a verification step not only at the end of the test, but also during the test to help us interpret the results. And this is absolutely useful if we get a failed test result, so we can diagnose whether it is because of querying the wrong points or missing a step change. And finally, we need to restore the original condition of the system. And this is really important if we have multiple tests to perform and compare on a consistent baseline. And also, this is considered a good practice to avoid a manual override that accidentally stays in the system forever. And we even in this study, we make the workflow even more scalable by generalizing the information querying process. This is because although HVAC systems are designed differently in each building, they still follow the same process flow and energy heat transfer process. So we can start by querying what are the central plants in the building. And then we follow the chilled and hot water loop to find the heating and cooling coils. And then we find which air handling units are supplied by those coils. And based on that information, we can find the downstream terminal units and the airflow sensors that attach to the HVAC zones. And we believe throughout this logic, the queries, the information process can be highly reusable for other applications. And here we show how we apply this workflow in our chamber to recommissioning the ventilation system for dynamic control. And this is to test whether we can modulate the airflow rate at the zone level by varying the supply fan speed set point at the air handling unit level. So at the beginning, we used the brake query to retrieve the information we needed for this particular task. That includes finding the sensor measurements and set point information. And then we include those information to a predefined sequences to test the modulation functionality. And this includes checking the read and write capability of the BAS system and the communication network, and also checking the override capability of the supply fan speed set point, and also the tracking of the zone airflow measurement. And then we can see after we increase the supply fan speed set point at the air handling unit, we also observed a significant increase in airflow rate at the zone level. And this is measured at the VAV box level. And so the modulation functionality is verified. And most importantly, the whole process actually takes less than 10 minutes to finish, where compared to a conventional practice, just mapping out the data points for the mechanical system manually could take weeks. So in conclusion, the primary outcome of this study is that we developed a generic and automated workflow for the HVAC functional performance test. And there are three major operational advantages associated. First, we developed a streamlined workflow that substantially require less time to finish. And secondly, we drastically reduce the operational burden by only requiring manual intervention at the very high level, for example, by selecting which air handling units to test if there are multiple for a complicated system. And most importantly, the whole workflow requires almost no customized configuration. That means it can be rapidly deployed across a diverse portfolio of buildings. And for the next step, we would like to quantify exactly how much time and cost we can save throughout this automated workflow and deploy this workflow in other commercial buildings to test scalability. So if you have a potential case study building in your portfolio, please let us know. And with that, thank you so much.